So hello, in this is assignment 4, and yeah, in the first task here, mm, yeah, I implemented AI for the NEM game using Q learning, and in this game, players remove objects from piles, and the player who removes the last object lose. And the player who removes the last object loses. The goal of this task was to make the AI learn good moves by playing many games against itself. In NIM class defines the rules of the game. The game starts with 4 piles, 1, 3, 5, and 7 objects. The function, moving to a function available actions, returns all legal moves for the current state. And the move function applies the selected action, updates the pile, switches the player, and checks if the game is over. Yeah. So about Q learning idea in class name AI. Yeah, the AI is implemented in the name AI class. It uses Q learning, which means it stores Q values for the state action pairs. A state is the current list of piles, and an action is a move like taking some objects from one pile. And the AI updates these values after every move, depending on whether the move was good, bad, or neutral. This function, so get Q value, its purpose is to return the Q value for a given state and action. If the pair doesn't exist yet in the dictionary, it returns 0. So this is important because at the beginning the AI has no experience. So unknown moves start with a neutral value. I convert the state into a tuple because dictionary keys in Python must be immutable. And update Q value. Update Q value. This function applies the Q learning formula. It calculates a new estimate using the current reward plus future rewards, and then updates their stored Q value. So if a move leads to a better outcome, its value increases. If it leads to a loss, its value decreases. So here alpha controls how strongly the AI trusts new experience compared to old knowledge. And yeah, here the best future reward. This function looks at all possible actions in the next state and returns the highest Q value among them. In other words, it estimates how good the future can be from that position. And if there are no available actions, it returns 0. And this helps the AI not only evaluate the current move, but also think about future opportunities. And choose action function decides what move the AI should make. If epsilon is false, the AI chooses the best known move. Yeah, and if epsilon is true, the AI sometimes explores random actions and sometimes uses the best action. So this is called epsilon greedy strategy. What about train function? Yeah, after implementing these functions, the AI can be trained using the train function. In training, the AI plays many games against itself. And after each move, it updates Q values and gradually learns which actions are better in different situations. So in my test, the AI was trained through repeated self-play, which is the core idea of reinforcement learning. In PlayPy, sorry, in PlayPy, finally, the AI is trained and then used in an actual game against the user. The line AI train 10,000 actually trains the model, and then play AI, it starts the game. Uh, yeah, actually, I've played this game a lot, and I've learned the algorithms, how to win, and when we lose. So actually, when AI starts first, there is a chance uh, that we can win because the example is given 1, 3, 5, and 7, and actually this is example where the position is good for the player who moves. No. This position is good for the player who actually moves second. Yeah, and if AI goes first, there's a chance if we know how to play, if we know the algorithm. There's a mathematical some mathematical yeah functions. Yeah. So to conclude, in this task, I implemented the core IQ learning logic for the NIM AI. The AI stores Q values, updates them after every move, and and yeah, estimates future reward and chooses actions using an epsilon greedy strategy. As a result, it is able to improve its gameplay by learning from experience. And moving to the second task. In this second task, I developed a machine learning system to analyze student behavior and predict academic performance. I used three algorithms: K nearest neighbors, KNN later, and for classification, linear regression for prediction, and K means for clustering. So first of all, I've created my own CSV file, my own dataset. It contains features such as study hours, sleep hours, phone usage, attendance, and so on. And I also included two target values. There are one categorical variable called final result for classification, and one numerical variable called final score for regression. The dataset was manually created based on realistic assumption. Yeah, and the students who study more and attend classes regularly tend to perform better, while high phone usage and stress negatively affect performance. Next, here KNN classification. I this function is to predict whether a student will pass or fail. I selected the features as input and used final result as the target variable. Since the target is categorical, I encoded it using label encoder. And then I split the dataset into training and the testing sets and applied feature scaling using standard scaler. And I chose k equal to 3 because the dataset is relatively small and this value helps reduce overfitting. And after training the model, I evaluated it using accuracy. And the model achieved high accuracy, accuracy equals 1, which indicates that the dataset is well structured and the model can correctly classify student outcomes. And after that, I used linear regression to predict the final score of students. I used the same input features and the set final score as the target variable. The model was trained on the training data and evaluated using mean squared error. So LOMSE indicates that the model predictions are close to the actual values. And I also here I also analyzed the coefficients of the model to understand the importance of each feature. And the most important feature is the one with the target coefficient is in absolute value. In my case, it was assignment completion, which means completing assignments has the strongest impact on performance. And I also performed a simple simulation to understand how changing a feature affects to the results. For example, I increased study for about by 2 and calculated how predicted score changes. And the result shows that increasing study time leads to an increase in predicted score, which aligns with expectations. And finally, K means clustering. I applied it to group students into different categories based on their behavior. I selected all features except the target variable and applied k-means with 3 clusters. Yeah, and I chose 3 clusters to represent different types of students. The scatter plot shows how students are grouped based on study groups, study hours, and past grades. After analyzing the cluster, I identified that 3 main groups. So cluster 0 represents low performing students with low study time, high phone usage, and higher stress. And cluster 1 represents, here it's green or blue, I don't know, represents high performing students with high study hours, high attendance, and low stress. And cluster 2 represents average students with moderate values in all features. So in conclusion, this project demonstrates how different machine learning techniques can be used to analyze student behavior. KNN was effective for classification tasks. Linear regression helps predict numerical outcomes. And k-means revealed hidden pattern in the data. So overall, the results show that the study habits, attendance, and assignment completion play a significant role in academic success. So actually, that's it. Thank you for your attention. Goodbye.